A few recordings ago, we did mention that how to measure the distance between a tree and a wall, and we agreed that someone will go and bring a measuring tape, and he's gonna go ahead and measure that distance between the tree and the wall. Then he will come and say that the distance was measured to be 30, and that's it. And we agreed that distance is what we call that the physical quantity that we measured, and we call that dimensions. And we did cover many videos so far on the dimensions and systems of dimension. And we agreed that this is the numeric values presenting the value on the tape that he measured, but without a full description here for that 30 as a number, it has no meaning, right? And we agreed that what add the meaning to the numeric value is what we call it the units. So units is the description or the description that give meaning for the numeric value of the measured dimension here. We have different systems of units. The most famous and used one is what we call it the number one is the standard international system, which most of engineering students know that system as SIU, Standard International Unit. In the SI unit, the basic dimension quantities, which is distance, time, mass, temperature. Then you can add the electric current, for example. That's another physical quantity. We can add light intensity, we can add quantity of substance and more. But again, remember, we talked about these five basic or fundamental dimension because we can drive or construct any other quantity out of it. So let's stick to these basic quantities here and see how we're going to express that in the SI unit here. So the distance measured in the SI unit can be expressed with the units of meter, and we can actually use small letter m to present that. Time is measured in seconds, and we use S small to express that unit. Mass is measured in kilogram, and this is presented by kg. And keep in mind, K is a small letter here. S is a small letter, M is a small letter. Temperature is measured by Kelvin, and this can be written as K capital. So that's K capital. That's the only capital letter in the unit. These are small letters, small letter here. Okay? Then, very similar to what we did, you remember distance. What is the dimension of distance? It was L, right? Now we are switching between unit and dimension. Time is measured by or identified by T. Mass was identified by M. And temperature was identified by theta, right? So keep in mind, let me use a different color here. These are the dimensions. While this here is presenting the units. Very similar, we constructed all other physical quantity to measure using these dimensions. We can do the same for the units. For example, let me use a different color here. If I talked about velocity, what is the unit of velocity? Velocity is distance over time. Distance is measured by meter, over time is measured by second. So the velocity has a unit of meter per second. That's a unit. What is the dimension of velocity? It's L t minus 1. Okay, now go for acceleration. Acceleration is distance over time square. So the unit is meter per second square. What is the dimension? L t minus 2. I'm trying to bring back the dimension side by side to the unit, so you can, guys, keep that in your brain and distinguish between both of them. What's next? Force. If you go back to a couple recordings, force is mass times acceleration. The mass has a unit of kilogram. Acceleration has a unit of meter per second square. So simply, the unit of the force is kilogram meter per second square, right? But what is the dimension? If you are doing FLT system, is going to be F. If you are doing MLT system, is going to be MLT minus 2. Okay? Always comparison, make the information stick to your brain. So that's why I'm trying to bring back the previous ones. But for example, when we start constructing the units of the force, kilogram meter per second square, some scientists found that this is maybe a long written unit, so they give an equivalent value for this. Kilogram meter per second square, the equivalent to what we call it? Newton, right? So that's N. So that unit here is equivalent to Newton. You realize I'm using small letter, small letter, small letter, small letter, everything small letter except this guy, K, and this guy. Can anyone tell me why? Yes, unit also is always using small letter except when you express a name of a scientist. Kelvin is a name of scientist, so the unit, as a matter of respect, it's K capital. Then Newton is a scientist name, so when we present that unit under his name, we have to stick to that to be capital letter. I have a different recording outside of that course explaining what is the difference between small and capital letter and when we use each one. I encourage you to go back and to look to that. But again, let's continue here. This is now the SI unit and how you can use the basic units to derive or construct any other units here. What else we need? Pressure. Let's do pressure. Pressure is force over area, right? So if I want to get the unit of pressure, the unit is Newton, that's a force, over meter square. You want to get dimension, you take the dimension of the force, which is F L minus 2. That's a dimension in the FLT system. If you want to do MLT system, it's going to be MLT minus 2 divided by L square. So it's going to be ML minus 1 T minus 2, and so on. We're going to practice more. I don't want to extend the time of the video, but let's practice more about the units in the upcoming video here. See you guys in the next recording.